What we're going to do is just go through some sustainable practices. Waste is a big deal, especially in the plastics industry, using recycled material. So we're going to go through a few of those, and I'm also going to reference some software and kind of go through from the design phase to the actual production phase. All right, so X-Rite Pantone, we are actually based in Grand Rapids. We are a worldwide company since the 1950s. We are a combination of multiple companies. Number one, X-Rite, Great Tim and Beth, like you said, merged 19 years ago. And then 2 years after that, we bought Pantone. So all we do is color control, whether it be formulation, QC, that's all we do. Okay. And so we are the biggest in the industry. So we have different types of spectros. The way that we are kind of separated internally is print and pack, which is our print and packaging side with inks, and then consumer products and materials, which is the side that I'm on, that does formulation for paints, plastics, inks, textiles. I do everything except textiles, but we do have applications engineers who handle the textile part for us. These are just some of the companies that we are partners with. You know, one of them says Clariant, but I know that is now PolyOne and Clariant became Aviant. But we've been with Clariant and now PolyOne Aviant for many, many years. We do formulation, correction, QC. They actually have well over 200 to 300 licenses of the software, and they share this stuff digitally. We're going to talk a lot about a digital way to share information. So here's what this is what we provide to customers when we are showing them how a color measurement program can help. Number one, improve time to market. So you're not being subjective. So the way that we see color is very, very subjective. We are easily fooled by what we see. Whereas when we can take it into a digital world and actually use numbers are our language. We actually are able to match colors, formulate, get approvals that are much, much quicker. So our time to market is much quicker, which means we're saving money. We can also align physical and digital. So when I have a physical sample, one of the problems with the physical sample is they will age, they will change. Whereas a digital is the fingerprint. So a digital, I can put that on like a cloud system, and everybody in my supply chain can access the same digital data from a spectra, measuring the object. And so we're all going to the same standard. So we're not hitting a moving target. We can improve our quality and compliance. Everything nowadays is being technology driven. One of the things our customers are coming to us is a lot of times they don't want to physically look at samples as long as they have physically came up with the digital components. And so we can go in and we can share that through digital. Now, one thing we talked about was Pantone, so X-Rite Pantone. What we have with Pantone is from book to book to book, everybody uses them, physical books. The problem is the books can age very, very quickly, and like a 107C Pantone color can be a different color from your book to another book. Whereas we have digitalized that. So you could actually connect to a cloud system through your software and everybody could download the same standard. So again, we're not hitting a moving target. And then once you do that and you get everybody in line, you actually can optimize your spend. So you're not wasting money. One of the problems that we have is through the design process, through the production, is you tend to have a lot of waste. Now, I know in the plastics world, we reuse that recyclable. We don't call it waste, we call it recyclable. But we can minimize that somewhat. We can still use it. We can use the software to help us use that, but we want to try to minimize as much as we can. So these are our different products. Like I said, I'm consumer products and materials. What we do is we have digital standards. We also have formulation software where we can go in and we can characterize your pigments mathematically in whatever resin system you use. And then when we formulate something, we can measure in a standard, and the math engine, which is proprietary to us, we can actually go in and try to recreate that standard using your pigment. So we're going to formulate and correct, if need be, use that. We can also use recyclable material in that. And there's different ways that we can handle that. We do have industry-leading handheld and bench tops. So most of the time, if you're not opaque, you're going to be using a bench top because you can do reflectance and transmission measurement. So if your resin is not opaque, we have the ability to measure through the sample. And we can control it using QC. So our software is actually QC, formulation, correction, loading of cone files, all in one software. So there's not different softwares, and they connect to stuff like Pantone Live. They can be shared via a database. So I could use a SQL Server database, and everybody could be downloading the same data, sharing data across our supply chain, internally, externally, however you want to do it. The other thing that we have is digitalization. One of the products that we have that came out a few years back is called Pantora. Pantora is a product where we can actually measure in standards, like a Pantone color, and then we can apply that color, not only the color, but we can apply like gloss, texture, if you have any type of special effects, through software where we can render that without actually having to produce it. So a lot of the automotive industry, you're going to have a lot of waste when you're designing something. So let me show you this. This is kind of what you're doing through a digital material industrial workflow. So you're going to have some type of inspiration where you're coming up with it, what colors you want to use. And then you have to have the product design and development. So this is where you're actually going in and applying the colors into whatever the product that you want to use. The next step would be production. You got to produce it. And then you have your advertising and marketing. So what we want to do in this digital materials in this industrial workflow is we want to all have the same color, which is very important. Now, in the product design and development, I can actually design something using software and a high-end monitor where I don't actually have to physically make the sample. For example, this is something that we just did with Volkswagen, where you can go in and I can 3D render in this case, a chair, and then I can apply different colors on here. I can apply different textures. Now, the colors are what I measure from a spectrum. So these colors are actual representation on a high-end monitor of what it would look like if you produce this. So without producing anything, I can change different colors. The one thing that I did a couple of weeks ago was we actually designed a mouse, a computer mouse, with a company, and we were able to design and change the colors on the mouse to get the product that we wanted, and we didn't have to produce anything. So you can actually get very, very detailed on your rendering. I can move this around. I can do different like lights that are hitting this. So I can change the light from daylight to cool fluorescent. So I can actually see what it looks like. And so I don't have to actually physically make a sample. Now, once I pick the color through this digital workflow, I'm going to use the same spectral data throughout the production, throughout the advertising and marketing. So whatever I design and I have my inspiration for my colors, it's going to be the same throughout this workflow. Now, when you go through to production, that's where you're actually physically formulating the color that you came up with. And so when you physically formulate, you're using your pigments, you formulate it, everybody agrees on it, and that would be our standard that we're using. And then I can take that to my advertising and marketing. So, but I can track every aspect of this. What I'm trying to do is minimize, number one, waste, recyclable material, but I'm also trying to minimize any variance that we have in the process. So from inspiration all the way to advertising and marketing, through that whole thing, I'm using the same color. So there's not anything that I have to change. Go back to my original slide. All right, and that product's called Pantora. It connects to software. You can actually connect to a multi-angle instrument, which is where I can get gloss, texture, any type of special effects, metallics, pearls, stuff like that you have in a lot of your high-end cars, high-end plastics, where you can actually go in and we can not make a sample, but decrease the waste. So we're actually being very, very sustainable. And we have some car companies that have actually already saved $1 million just in this process where they don't physically make samples. Formulating the color, what you have to do is you have to pick out how you want to do it, what your pigments are going to be, your additives, your resin, your colorants. Now, 99% of what I do is formulation. So I do a lot of consultant work. I do a lot of formulation work with paints, plastics, inks. One of the things that when I say resin, I mean everything but pigment. I know there's a different resins, you got different additives and everything, but we're actually going to characterize that data. So if you have a different additive, a different resin, and it has any type of a color to it, like it might go yellow, it might go whiter, we're actually physically, mathematically characterizing that resin. So if I change resins using the same pigments, I don't have to make a whole new coloring file for it. So we got to pick what type of pigments we want to use. We're generally, when we're making something in a formulation world, characterizing the pigments, we're going from whatever the max load of the pigments in our resin system, we're going to characterize it from max load down. So we want to show at different concentration ranges, mathematically, how does this pigment react in the resin system from a color perspective. Now, once I characterize that data, then I can go in and I can use that mathematical color file to formulate, correct, to work off recyclable materials, because my resins, my pigments are mathematically characterized. And you'll probably hear the term absorption and scattering. Everything that we deal with is light, energy, interaction. So when you interact with an object, that object is either absorbing energy or it's reflecting energy. And so what we're doing mathematically is we are showing how much of a particular color in a resin system absorbs the energy or reflects energy. Now, what we see by our eye is the reflection. And so what we try to do is we try to recreate with our pigments that are characterized in the mass system what a standard is absorbing energy and reflecting energy, and we just try to recreate it with our pigments. That's basic of formulation correction system. First of all, to do all this, you have to have some type of color measurement, which are spectros. All a spectro is it measures the energy, we call it across the visible spectrum. The visible spectrum is where we see color, where we pick up energy by our eye. So all we're doing is we're just measuring the energy from an object across that visible spectrum. If you think of in the electromagnetic spectrum, the visible spectrum is just a very, very small section of where we see energy. So we have detectors in the back of our eye that pick up this energy. So a spectro is actually measuring across that visible spectrum. You then have to have some type of software tools for formulation, prediction, for QC. So that is, again, we're characterizing what we're doing. And then you have to have your processing equipment. You got to have your extruders, your injecting molding machines. Now, every one of them is different, obviously. All right, it's based on what you're producing. So what we're actually doing is when we make these samples, we are including that data in the math data for the colorants. And then also you have to have calibration and standardization. So with the spectro, you have to get it calibrated every year. We also do, in like a supply chain, we have software that's proprietary where we can mathematically fix your instrument if it starts to drift. Every environment, every plant, even supply chain might be different. In other words, some of them might be dirtier than others, some of them might be hotter. So it can change your instrument. But what we do is we actually use a product called Net Profiler where we actually bring in your instrument back into spec. So first thing I talked about was digitalization. So everybody in my supply chain, when I'm using electronic digital data, we can take the instruments out as a variable because they're all measuring the same. Tips and tricks for reducing waste. Number one, what we're trying to do is when we formulate something, we are trying to minimize how many corrections we do to formulate. We also can store those recipes in a database, pull them back up. We can search on them. We can also use that stored data to help us better formulate an unknown standard. So I can go in and I can store good known recipes in my database. And then when I go through my math engine, I can have the math engine pick something that I've already measured, that I've already formulated, that meets all the same requirements. That means the same pigments, the same resin, everything, where I can go in and I can search that and then I can do a correction. So the first shot that I have on a recipe is actually a first correction from a good known recipe. So what I'm doing there is I am decreasing the amount of time it takes me to match something. I'm decreasing the amount of corrections I've got. We can also add metadata like polymer type, processing, end use requirements, where we can update. All this is where I can search through it. So I can go here and I can add metadata. Let me just show you real quick in the software what I mean by metadata. So when I look at software, and this is our software, I can go in and I can add, now this is a measurement. I can actually add this data here. I can just type it in. I could have drop-down levels, whatever you want. Now this is all configurable, so I can pick what metadata I want to store. Now when I store this in my database, I can actually search through my database, and I could use any of these as a search feature. So not only can I search on the color, but I could search on a certain resin type, a certain supplier, whatever data you want to see. So in our digital world, a lot of our customers are already using this, and this streamlines everything they're doing. So they don't have to search a whole database. They can actually streamline for the process that they're using today. Now, every bit of this is shareable. So I could actually share this data across my supply chain, and everybody can access this same data. So if I put something in there, and I live in North Carolina, and I had a plant in Michigan, my Michigan plant would automatically be able to download the data. They could search on the data. All right, so what we're trying to do here is we're just trying to increase the time it takes us, decrease the time it takes us to get a good acceptable match. Digital, you also have predictive modeling. The predictive modeling has to do with our formulation engine. The formulation engine is called multiflux math. It's the most robust math on the market. Not only do we take into account the color, like I said, the absorption scatter, but when I characterize a pigment in a resin at that given thickness, I'm also characterizing, okay, this is how much white it has in it, this is how much red it has in it. And then I am measuring the sample reflectance transmission. Since I'm measuring through the sample, at that given thickness, at that given loading, I can actually predict how much hiding is going to be in the sample. So I characterize that data. When I formulate, I could say, all right, try to make this sample at 20 mils, whatever. And I could say, all right, try to make it opaque if possible. And the math engine figures out the loading level for me to try to achieve that color and that opacity at whatever film thickness I select. So what we're actually doing is we are minimizing hits that we have to do to try to make it opaque. Generally in the past, you've always had to guesstimate how much of a hiding you needed. You'd have to guesstimate the loading level to achieve that. And a lot of people would overload. So if 8% loading, pigment loading is going to make me opaque, they do 10% to make sure. So what we're doing is we're actually mathematically characterizing that. So we can actually save money in a year by not overloading our samples. We can also do metamerism. I don't know if you know what metamerism is, but if you ever go and take a dress shirt and you go to some department store, it's got cool white fluorescent lights, and you wear a tie, or you try to find a tie, and the tie matches under that light source. All right. You go out the next day, you wear the tie, now you're in daylight, and the tie does not match the shirt anymore. What happens is the color components in the tie are different than the shirt. They matched under certain lights, but they don't match under different lights. What that is metamerism. So what we're actually doing in our math engine is we are minimizing that. So when we try to recreate the curve of the standard, we also, for our primary and secondary light source, illuminant, we are matching the color, perception of the color, so we're minimizing metamerism. So a lot of times you don't know when somebody sends you a sample what type of sample it's going to be. It might not be a plastic sample, for example. It might be a Pantone book sample. Well, a Pantone book sample, you're always going to be metameric to it because it's not the same components in that Pantone colors that you have or the pigments that you're using. So the predictive modeling actually kind of helps us minimize that illuminant metamerism problem. Again, we're also doing pigment loadings. That's all characterized, all right? And then we can also optimize additive components. What that means is we can minimize the amount of pigments that you're using to formulate. So again, we're always trying to save money and match the color to a given thickness to a different opacity. So it really cuts down on, at the end of the day, waste, because if I'm guesstimating before I make something, loading, I might have to guesstimate multiple times. I might have to move the loading up and down and make samples. Regrind, recycle. If you're in the plastics industry, you understand a regrind. I was at a flooring place last week, and every time we go in and we grind their material up, they use leftover flooring. They have to. It's a part of the process. So about 40% of their material that they're producing is going to be a recycled material. And what that means is every time they use a new regrind, whatever they get in the door, that is going to change the color. So even though they have a standard recipe, what we actually do is we have to do a correction every time to that standard recipe. There's multiple ways we can do the correction. Number one, we can actually go in and say, all right, here's my recipe. Here's what's in it. I can read in my trial. Now give me a correction. I can also do something called batch recycle, which is a new component that we have in our latest version of software, where I could go in and if I make something and I don't really know what's in it, I can measure in the trial. Here's my standard. I can pick up to 20 pigments in whatever resin system I characterized, and I can try to correct that. So a lot of places we have, since they're always using recyclables, they don't know what that recyclable is when it comes in the door. They have no idea what's in it. And so we use these tools to actually go in and minimize the amount of corrections. So we are recyclable materials regrind, you've already paid for them. It's money that's already been spent. Now you're using that, helping sustain the environment. Obviously, it's not in a landfill, but you're also saving money. So recycled materials, you have to go in and say, all right, what are my stabilizers to do this? All we're doing is we are formulating it based on whatever you have in it. And we're using our pigments. Common challenges, everybody's seen this, color fading, inconsistencies, contamination. Contamination is one of the biggest ones that I see, where you're not totally cleaning out your mold, your extruder. You might have contamination coming in the door. You certainly have contamination with regrinds. And so what we can do is we can actually use our math engine to help minimize not only and show if we have contamination. So we can actually track this data, but we can also go in and help correct it. Now, one of the things that a lot of people don't do, that they should do when they have a color system, is they should track the process. So any type of process variation, I can use the system, QC, not formulation, but I could use the system to actually track it. So incoming raw materials, I can measure to make sure that my incoming raw materials are consistent. If I have an incoming raw material that's off, well, I don't have to make a final product. And then at the final product stage, I say, hey, there's something wrong here. I can actually attack that before I even make a sample. So I go back to my pigment supplier, hey, there's something wrong here. This is not the same pigment. It's because it's going to change my end product. So a lot of things we can actually track. We can, a lot of places have first, second, third shifts. They might do differently in first, second, thirds. I can actually track what my workers are doing when they're actually physically making something. You might have heard of the coffee cup method before of weighing. That's where you grab a cup and say, yeah, that looks like 10 grams instead of actually weighing it. Well, I could track that. I could see that in the data that's coming back through QC. So what we want to do is we want to try to go in and minimize as many process variations as we have just by tracking the data. All right, material capability. Again, this is a lot of stuff that you have with regrinds where they might not be compatible. We have to do that first. When we are formulating something, we're making those pigments in whatever our polymer is, whatever our resin is, that is useful for those pigments. In other words, I can use those pigments in that polymer system. Whatever my carrier resins are. You hear of stuff like master batches. When I'm making something, I want to make sure that my resin is compatible with the product. So I can actually have different colorant files for different types of resins. Now, we don't have to make a colorant file for every resin as long as the pigment is compatible with an alternate resin is what we call it. Calibrating resin is what I make all my samples in. But as long as it is compatible with that, I can just make the samples for that resin and then pick what resin I want. So for example, just to show you here in software. So this would be my resin system. These are all my pigments mathematically. So what we've done is we have characterized these pigments. These are just letdowns. And then what we do is we take each individual sample and we just say what's in it. So in this case, this has this amount of resin, this amount of pigment. We do different mass tones, do mixes of white, mixes of black, my high scattering, my low absorbance. And then what this is the back fit calculation. So this actually takes every sample and formulates it back to itself. So we can see how good our samples are. So all we've done here is we show not only the loading levels, because we're showing the computer the loading levels, but at that given film thickness, how much hiding it is, which is the transmission here. So this is how we are going through and we are minimizing our formulation and our corrections because we don't have to guesstimate what we're doing. The math engine is doing a lot of this for us. So when I formulate, I can pick a standard, pick whatever pigments I want, and then I could say, all right, here's my thickness. I could change it. And then I could pick like an average transmission. So if I say, all right, I want to make this translucent. So 10% transmission is translucent. Now, when I formulate that, it would give me a recipe. And everything on this screen is configurable, by the way. So here's my recipe. Whatever I wanted it. It's going to show me percent and actuals. So here's my batch size up here. And then this is in grams. I could do grams, pounds, tons, whatever. And then I would go make this, and then I could actually do a correction on it. So when I go here and I show what the trial looks like, I have my trial here. I could say, all right, let me do an add to this. And it goes in and it tries to correct wherever I'm at now. So this is just the flow for what we're doing. All this, we're able to do it because we have characterized our pigments. And we have this library that we're doing. Environmental factors, temperatures, humidity, light exposure. One of the things on that instrument I showed you at the beginning is it takes a temperature and a humidity every time you take a measurement, and it stores that with the measurement. So you know the environment that you're measuring. Temperature, most pigments are thermochromatic. That means they change colors when they go up or down in temperature. So since we can actually characterize that, we're actually showing per the sample what the temperature is. We can actually show the data if we have to go back and look at some type of process issue. You got to have controlled environments, heat stable pigments, light stabilizers, all that. But even in our accelerated weathering test, we can go in and we can show how the color is changing. So we can measure that in a QC. What we offer is actually not only the software, but we train you on it. We teach you how to do it. We offer remotes. We offer any type of on-site time. This is what I normally do. Last year, I was on the road 42 out of 52 weeks. One thing that we have is we have a lot of experience. So in our applications, engineers, there's 6 of us. Most of us are over 20 years experience. I think there's only one of us who's not, and he's been with us about 12 years. And so we have a lot of experience, not only in the plastics world, but in paint and inks and textiles. Of course, color education, we have webinars. X-Rite.com is our website. We have a lot of free things on there, webinars, white papers, resources, things like what is illuminant metamerism, what's D65, that's daylight, illuminant. So a lot of that stuff is on there, and we always keep putting things up there every month. And it's 99% of it's free. Okay? If it's not free, it'll show you on what you're trying to look at. It'll tell you how much. And you can search on that versus plastics versus paint, whichever thing you're looking at. I know we're on the plastics here. Now, we are a global company. Like I said, we're based in Grand Rapids, Michigan. So all our manufacturing, besides our light boxes and some of our inline things, are done in the U.S. Our light box is made in China. Our inline is made in Germany. So in our Grand Rapids, Michigan facility is where we are making our products. So it's all local, everything. But we also have regional support and services throughout the globe. So a lot of companies we deal with are global companies, and they have offices throughout the world. So they have people like me in different areas. We have service in different areas. Globally, one thing about our industry, it's a lot of people stay in our industry for a very, very long time. So most of the people that are globally for us have also been around for over 20 years. So globally, we have a tremendous amount of experience also. So if you got somebody local, if you're dealing with somebody in Asia, you're dealing with somebody who's living there, who knows the culture, knows the language. These are our different things that we offer, XRite.com. We're obviously on LinkedIn, YouTube. There's a lot of YouTube videos out there. Let me show you one other thing in the software. From a quality control perspective, I can actually go in, and I'm going to highlight these. Now, I like this view because it shows me a good process variation. So I could go in and I could actually track based on a Delta CMC, a DL star, DA star, DB star, what I am running like in production. And I could pull this data back up. I'm going to maximize it so you can see it. So here is my tolerance, and these are saying that each one of these are in spec based on whatever my tolerance is that I've set. And I could actually double click on some of these. And when I go back to the main screen, it actually shows me which sample this is. So I could track this. From my experience, people really want to use the software to formulate and correct, but they don't use it to the full capability of trying to figure out the process, what their process variations is. A math engine will be as good as your process variation. So, like in textiles, you got a higher process variation. You have a higher process variation in plastics than you do in a paint. You have a higher process variation in a translucent plastic than you do an opaque plastic. So this can actually help me see what we're actually doing in production when we're making those. In this case, I can actually minimize the waste. So I could actually stop this if something goes off in production when I'm tracking it without them having to make a lot of products and I got to go and work at recyclable. I got to use it. I got to scrap it. So there's a lot of things in the software that you can do that most people don't, unfortunately. But one of the things is that I really hit on is process variation. All right. Any questions on any of this?
Thank you. Let's take some questions from the chat window. First question, we often measure color with X-Rite with white and black backgrounds on semi-transparent materials. Is one preferred over the other?
Yeah, you have something called, so you're backing it with the black and the white, contrast ratio, that's reflection. One of the issues that you have doing that is you have something called edge loss. And if you think about a plastic chip, right? So when the light flashes in the spectro, if it's translucent, it goes through the chip, hits the substrate, and then comes back to the detectors. What you lose is you lose light outside the surface. Now, if you're dealing with a thin plastic film, then you really don't have a lot of edge loss because it's like almost like a paint film. But anytime you're dealing with anything that's thicker than that, then you have that edge loss phenomenon where I'm losing light and it doesn't get back to my detector. Whereas when you're doing reflectance transmission, you're only measuring through the sample on a transmission. So it's not bouncing, coming back through the sample. I'm minimizing the edge loss. Now we can do things depending on how thick the sample is in reflection to minimize that. In other words, I could over illuminate the sample. I could have a bigger aperture, but then I measure something very, very small. So in the instrument that I showed you, that was our 7000 series, CI 7000s. You got different apertures. You got a 25 millimeter hole, a 17, a 10, a 6, and you can even go down to a 3.5. So there's a lot of things we can do, but it's better to do reflectance transmission. So anytime I deal with a customer, and the first thing I ask them is your resin less than opaque? If your resin's less than opaque, we get better characterizations by doing reflectance transmission.
And then they also have a follow-up question. Same question for UV cal and UV excluded.
Okay. So UV cal, you actually have, and it's on certain instruments, it's on our bench tops, some of our handhelds. A UV cal, you actually have a white cal tile that has a CIE whiteness number on it. And those are good for a certain amount of time, generally a year, because they will lose the optical brighteners in them. And then you have a filter inside your instrument. So I would go in and I would measure that tile, and the instrument is actually moving the filter until it matches whatever the CIE whiteness tile is, whatever that number that you inputted. Where if I'm doing a UV cutoff, that just means I'm cutting everything off at 100% reflected. So if I have any type of optical brightener or fluorescent, when you look at a curve, the curve would go up above 100, then you wouldn't see anything, and then you'd come back down from 100. So any type of material that has optical brightener in it, fluorescence, you need to have a UV calibrated instrument. Like I said, you can do that on some handhelds. You can do that on pretty much all the bench tops. For example, in the paper industry, they are, by federal law, when they measure the brightness of a paper, because they can charge more for higher brightness, has more UV in it, they got to be able to track that accurately, and that's what the UV tile is doing. And that is calibrated per instrument, by the way.
Next question. Sometimes we get samples from our customer to match metallic samples, but our X-Rite isn't able to pick correct color measurements. What can be the best possible solution for getting correct color values?
Okay, so anytime you have a special effects, pearl, metallics, you really can't measure that on a single angle instrument. So that's the one that I showed you. It's got a sphere inside. We do have multi-angle instruments that we sell. A multi-angle instrument is measuring at multiple angles at one time. So you would have something like 120, 75, 45, so on. And then in the software, you're going in and you are having a different curve for every one of those angles. They use that almost exclusively in the automotive industry. We are actually have come out now with a math engine, a software that we can characterize and formulate using metallics, special effects, pigments. But you also have to have a multi-angle instrument. So everything that I've shown you so far is on the single angle instrument, the math engine, but we do have the multi-angle.
Next question. Are there any special considerations for glass or mineral filled resins?
What was that again? I'm sorry. Repeat.
Are there any special considerations for glass or mineral filled resins?
Yeah, the process variation goes up a little bit with those just because of the glass in it and the way it is refracting the data. We do have a lot of companies that are doing that are using glass materials, that are using, they're coloring the glass materials. It really depends on if you're going to try to make it opaque or not opaque. It's still just a resin. We still have to characterize it. We would characterize what's actually happening. So generally what you're going to do is you're going to take an average reading of the resin and of the material. You can take up to 99. Nobody does that. But like on that, we would probably take an average of 3 or 4 to average out some of those differences and actually move the sample. So we do have a lot of experience with that. I've done a lot of those type glass-filled resin systems. It's doable, in other words.
Is there an X-Rite guide online for getting set up with formulations on existing hardware, both regarding quantity of single colorant samples and mixtures, as well as how to actually get a database connected into the eye control software once everything has been prepared and read in?
Yes. So we call our software color control or color eye control. That's actually 2 different things in the software. There's a QC portion and there's color eye match, which is the formulation, correction, loading of coloring files. They're the same software. So you're licensed either for QC or you're licensed for Color Match Professional, which both QC and the formulation engine. So if you only have QC, you can upgrade to the iMatch. As far as how do you make the samples that we do, we walk you through every bit of that. So we will actually take your max loads of your pigments in your resin, and we will give you a spreadsheet to show you the samples to make, and then we teach you how to load it. So what we're trying to do is train the trainer. So somebody like me, I'd go out and I would train you so you can train the rest of the people in your company, and we can train multiple people, obviously. That's 99% of what I do. I do a lot of consulting work. So last week I was at a place, we loaded in a color file. We had already specified the samples that we're going to make. And then once we loaded it, we taught them how to formulate and correct. And then we do remotes afterwards to help them if they have any questions. Because when you're learning software, you only learn about 10% of what you're taught. So you don't really know what you don't know until you start playing with it. But yeah, we offer those. We have not only trainings, we do remote trainings, but we also have all documentation on that too. PowerPoints, documents, step-by-step on all of it.
Okay, next question. How does X-Rite's formulation correction software help with off-shade batches because of the use of recycled materials?
Well, there's a couple ways we can do it. Number one, we can just use the correction routine that we're normally using for non-recyclable materials. Depends on how far the recyclable material takes the sample. In other words, how far does it change the trial? So I could have a standard recipe, right? I could go in and I could put in, like I said last week, 40% recyclables. Now I know what's in it. I know the recyclables is part of the resin. Now I can go in and say, all right, here, go add this from my pigment file. Go add these colors, this amount of colorants to it to try to correct to the standard with the recycled material in it. The other way to do it is something called batch recycle. Let me just show you that. What a batch recycle is this. Now, this is if something is far off, which happens. I can go in and I can have my standard. I can have my trial. Say, this is my batch quantity. This is how far I'm allowing the math engine to go. Doesn't mean to go that far. And then I can pick up to 20 pigments. And what the math engine will do, it'll go in and say, all right, here's my standard. Here's where my trial is. Let me try to correct it to the standard. And if possible, it will give me the add amounts down here to correct. Now, generally, you want to use kind of common sense stuff. And I have a lot of customers doing this now. So when we designed this math engine, we had 5 beta sites, and all these beta sites did was batch recycle. So they always used up to 60% recyclables. And so sometimes they would be 3, 4, 5 delta E away from how they actually made it. So in other words, they'd add the recyclables, they'd take it 4 delta E away. So we were able to get it under a 1 delta E in 2 corrections by using batch recycle. Again, it's still using our math engine, but I don't know what's in the batch theoretically, so I'm just correcting with whatever pigments I use. And it's always trying to minimize the amount of pigments.
Next question. How do you share digital data with other locations or the supply chain?
Digital data?
Yeah.
A couple ways you can do it. Number one, we could share a database. So if we had a SQL Server database that could just reside somewhere on the server, even if I had my software standalone, I could point to that SQL Server. So I could go here and I could actually set up a SQL Server, point to the database that have their login. IT does every bit of this. And then every location can log in. So I got a big plastics company that has a server in Charlotte. Worldwide, they have over 250 connections to that one database. They can actually, in the database, subset that database. So I could go in and I could go in here and I could say, all right, for each one of these, when they log on to the system, I could give them a region and a locale. And I could say, all right, I'm in the States. I'm looking at Mexico's data. I can grab Mexico's data, but I cannot modify their data. So I can't override it, for example. So this is in the database. So when I go in and I search the database, okay, if I have the region and locale set up, they would show up on regional locales here. I could also subset my data with different, tags. So I could have every one of these tags that I could subset. So everybody is sharing the same data. It's almost like a cloud system. And that could reside anywhere. You could reside that on like an Amazon server if you want. Again, the software can be standalone, so it can be on your PC, or I could have the software on a server and everybody remote desktops into the server to run the software, just depending on what kind of configuration you want. You could also, these are jobs. I could go in and I could email this job to somebody. They have the software, they open the job up in their software, and they would show exactly everything that I have in there, including if I formulated, if I correct all the recipes, everything. So there's multiple ways you do it. Now, if you're dealing with companies in your supply chain that have different software packages, in other words, there's not an X-Rite software package, all right, I can also export the data out into these different formats, and then they could import that into their software. So if somebody sent me something from a competitor software system, I could go down here and I could find the data, and I can import that into my software. So down here at the bottom of this job, I just imported this data. And then in that, I could actually go into the properties of it, and I could actually see exactly how they measured it. What instrument, how they did it. Was it a 045 instrument or spherical, reflectance, reflective transmission, overload or dark? I got all that data. So there's multiple ways you can share data across your supply chain, which is very important with digitalization. So you don't just have to have our software to share.
Okay, and those are your questions. Thank you for an enlightening presentation. Do you have any final comments?
No, if you need any information from us, please go to our website, xrite.com, and we can get you any data. You can actually go there and just look on there yourself. It's all free. You can set up a My XRite account. A My XRite account is free. You just have to have an email address. And the My XRite account allows you to go in and look at all these webinars and download documents. But I appreciate everybody's time. Thank you so much. Hope you have a good week. Stay cool. I know it's hot out there.